All right, we're going to review a topic that you learned in Integrated 2, and it is going to become essential for us in our trigonometry chapter, which is our next chapter. So I figured during this time, while we're out of class, normally, we'd review this pretty quickly in class, but it's expected that you know it fairly well. So instead, since we've got this time, we're going to make sure you know it really well, and then we will not have to go over it again, at least not in detail. So this is special right triangles. There's only two special triangles, a 45, 45, 90, and a 30, 60, 90. So we're going to go over the easier one first. What I have on the screen already is what I call the key. Okay, this is the key to doing all of these problems, is knowing this. You either memorize it or it's up in our classroom, so you could always look for this. Sometimes people use X here. In fact, I think maybe in the classroom it might have X. I do have a reason that I like A better, but X is fine as well, so whatever you want to use. All right, so what we're looking at is that in a right triangle, so you got to make sure it's a right triangle, 45, 45, that means it's isosceles because it has two equal angles. That also means it has two equal sides, and that's why this one's a little bit easier. I just realized that I wrote this wrong. This should be a 2 right here, so please make sure you adjust that. Yeah, that should be a 2. So that side is different. That's the hypotenuse. Remember, the hypotenuse is the one across from the 90-degree angle. All right, so let's do our first example, and this one's going to be an easier one. So we have a 45, 45, 90 triangle, and we are going to have a side, let's do 5 here. Okay, so what we do first always, okay, this is our first step, is to write the key right directly onto the triangle. Now you'll notice this triangle is situated differently than the key, so we have to be careful. We want to know the hypotenuse, so I always recommend drawing an arrow from the hypotenuse, or from the right angle to the hypotenuse. And that way we know, okay, well, that is the hypotenuse, so the other sides are our A. So I put A on these two sides, and on this side I put A root 2. Now, when you do that, you are going to only have one side that has both an equation and a number. Okay, notice only one side has two things, this side here. This only has one, this only has one. That's not what we want. Because we are going to write an equation, and in order to have an equation, we need two things. So step 2 is our equation. So our equation is going to be A equals 5. Now you might be thinking that's not really an equation. It is, it's just a very easy equation. And on our step 2 on equation, we also want to solve it. Hey, it's already done. That's why this is an easy one. So A is 5. Okay, once you have your equation and you've solved it, our third step is to plug it back in. So we want to kind of focus on these steps. Write the key, write the equation and solve it, plug back in. Once we know A equals 5, we're going to plug that back in. Okay, let's plug A in here. What's that side? 5. Let's plug A in here. This side is 5 root 2. And now we know the length. Two sides have a length of 5. The other side has a length of 5 root 2. What happens is this becomes a lot quicker, hopefully for you, is that we see this triangle. I'm going to redraw that a little bit nicer. Okay, as long as we know it's a 45, 45, 90, if you see this is 7, you hopefully start getting better and say, okay, well I know the other side matches and the other side is 7 root 2. That's a lot easier than using trig or the Pythagorean theorem to solve. They do get more difficult sometimes though. So we want to try one of those. All right, so here is a new one. So we're going to follow our steps. First step is to write the key. So I'm going to find my hypotenuse. That's my hypotenuse, so these are my sides, A, and my hypotenuse is A root 2. So step 1, we put the key on. Step 2, write an equation. So we have to find the side that has two things. That would be this side here. So I'm going to write A root 2 equals 9. And in writing the equation, I also have to solve it. I want A alone, so I'm going to divide by root 2. I get A equals 9 divided by square root of 2. We are not supposed to leave a square root in the denominator, so we do something called rationalizing. which you have learned, but let's review what that means. What we can do is if we multiply by this, which is really just 1, so that's why we're allowed to multiply by that, it will take care of that denominator. On the top we get 9 root 2, because I went straight across. And on the bottom I go straight across. Root 2 times root 2 is root 4, but the square root of 4 is just 2. So by multiplying the same square roots together, I get that number free and clear. And so there we go. I have a equals 9 root 2 over 2. Now 9 over 2, those are numbers outside. If that reduced, we could reduce it, but 9 over 2 does not, so we are going to leave that. So we're going to plug that back in up here. A equals 9 root 2 over 2. Okay, well what is this side then? A equals 9 root 2 over 2. And this side would be 9 root 2 over 2. Okay, let's look at our next one. First step, key. 8 root 2. Second step, equation. Where do I have two things? Right here. I'm going to make an equation with that. So I have a root 2 equals 8. I'm solving for a, so I divide by root 2. I divide by root 2. I cannot leave root 2 in the denominator, so I rationalize, which means I multiply by 1. Straight across here, I get 8 root 2. And on the bottom, when we multiply a root by itself, we get that number free and clear. But this time, 8 over 2 does reduce. 8 divided by 2 is 4. So this one just comes out looking a little bit nicer. A equals 4 root 2. So I have solved my equation. Now I go and I plug it back in. This side is a, so it's 4 root 2. This side is a, so it's 4 root 2. And now we have all of our sides. All right, now this is our second special right triangle, the 30, 60, 90 right triangle. It is very similar in the way we do it, except that it has 3 different sides, so we kind of have 3 different types of problems. One I consider very easy, the second also easy, just not very easy, and then the third is the harder one. All right, something really important on this one is that we correctly identify the sides. Because there are 3, we cannot assume that it's drawn to scale. So the first one I always recommend is the hypotenuse, because we're pretty good at identifying that across from the 90-degree angle. So that's our hypotenuse. We always put 2a on that side. Okay, the second one is the short side. Now the short side is also going to match with the smallest angle. So we find our smallest angle, which is 30. Across from that, that's your short side. That is actually the side we want. If we have the short side, it is very easy to do this problem. We will not always have it. Okay, if you find those two, then the last one is automatic. The 60-degree side is going to have that a root 3. We call that the long side. Okay, so over here on my figure, let me put a number on. We're going to have a 7 there. So what I really want to do is make sure that I identify correctly. So my first step is to put the key on. I'm going to find my small angle so that I can get my small side. That's my A. I'm going to find my hypotenuse. That's my 2A. And I'm going to find my other side, which is the a root 3. Once you have 2, that third one's easier. All right, I need to do my equation. So I am going to find the only side that has 2 things. There it is. I make my equation, a equals 7. I solve my equation, which I really don't have to do. It's already solved for me. I have a equals 7. So I'm going to plug that in now. A is 7, so this is 2 times 7, which is 14. That side has a length of 14. It's always double that. So when we get better at this, we'll know that we can just double the short side to get the hypotenuse. And then over here we have 7 root 3, which is just 7 root 3. It's not a nice side length, but it is what it is. Okay, let's look at the second easiest type. Okay, so let's identify our sides. So I'm going to start by identifying my short side. There's my 30 degrees over there. That's my A. I also need my hypotenuse across from the 90-degree angle. That is my 2a. And that leaves me with my third side, a root 3. All right, let's find our information that we have two pieces on, and that is 2a and 10. So I get the equation 2a equals 10. And I need to solve that. I'm going to divide by 2, a equals 5. Now, sure, that was not as easy as when I did the first one, because a was 7 right away. I did not have to solve. But come on, that's an easy equation to solve. We're dividing by 2. It's always 2a, so it's always dividing by 2 on that side. So not quite as easy as when you're given the short side, but pretty easy still. Now, once we have a equals 5, we do the same thing. We go back to our sides. We say, okay, what's a? 5. What's a? 5. And now we have our side lengths. The 3 side lengths on this triangle, get a highlighter here, are 5, 10, and 5 root 3. We knew the 10, we found the side lengths of 5 and 5 root 3. All right, I purposefully drew this triangle not to scale so that you cannot really tell which side is the short side or not. And that's because we have to be very good at our identifying. So we want our short side, so we find our small angle across from that is our short side. That's going to be our A. Our hypotenuse is across from the 90-degree angle. That's our 2a. And that leaves us with the extra side, which is a root 3. All right, let's find our equation to solve here. So this is the side that has two pieces of information. So we get a root 3 equals 12. We need to solve for a, so I'm going to divide by root 3 to cancel. Just like in our 45, 45, 90 triangle, we can't leave a square root in the denominator, so we need to multiply. And we want to multiply by the same exact square root. So to be fair, I do that on the top and bottom. On the top, I get 12 root 3. On the bottom, root 3 times root 3 is root 9. Square root of 9 is 3. So again, when you multiply a root by itself, you get that number free and clear. Now we check, does 12 over 3 divide? It does. We get 4 root 3. So we just solved here. We got a equals 4 root 3. Let's take that up to our triangle. Here's a, 4 root 3. That side is 4 root 3. This is 2 times a, which is 4 root 3. So I multiply there. Outside numbers can multiply together. 2 times 4, we get 8 root 3. So the sides of this triangle are 12, which we knew, 4 root 3, and 8 root 3.